The dawn of time, the Big Bang. Our universe begins with an event of unimaginable power and energy, a moment that set everything into motion. We call it the Big Bang. Picture, if you will, all of space and time compressed into a single point, a singularity of infinite density and temperature. This point, smaller than an atom, contained the potential for everything we see around us, every star, planet, and galaxy. Then, in a fraction of a second, it exploded, releasing an immense amount of energy and light. The Big Bang was not an explosion in the traditional sense, like a bomb going off. It was an expansion, a sudden stretching of space and time itself, causing the universe to grow exponentially. Imagine a balloon inflating rapidly, its surface expanding in all directions, representing the fabric of space-time. That's a simplified way to picture the early universe, a rapidly expanding bubble of energy and matter. From this infinitely small point, the universe began to cool and expand, allowing the formation of the first particles. As it did, energy converted into matter. Following Einstein's famous equation, E equals mx squared, transforming pure energy into mass. The very building blocks of matter, quarks and leptons, started to form, setting the stage for more complex structures. This early universe was a chaotic and energetic place, a seething cauldron of particles colliding at incredible speeds, creating a dynamic and turbulent environment. But within this chaos, order began to emerge, setting the stage for the formation of everything from stars to galaxies, leading to the universe we know today. The universe takes shape, cosmic inflation, and the first elements. In the first fleeting moments after the Big Bang, something extraordinary happened: cosmic inflation. The universe, still in its infancy, underwent an exponential expansion, growing at an unimaginable rate. It grew at a rate faster than the speed of light, ballooning in size in a fraction of a second. This rapid inflation smoothed out any initial irregularities, like wrinkles on a fabric being pulled taut, creating a more uniform universe. As the universe expanded and cooled, the primordial soup of particles began to settle, setting the stage for the formation of matter. Temperatures dropped enough for quarks to combine, forming protons and neutrons, the fundamental building blocks of atomic nuclei. This era, known as nucleosynthesis, marked the birth of the first elements, primarily hydrogen and helium. The universe, still incredibly hot, was dominated by a sea of protons, neutrons, electrons, and photons, creating a dense plasma. Light couldn't travel freely in this dense plasma, as it constantly scattered off charged particles. This scattering made the universe opaque, preventing light from traveling long distances. Over time, the universe continued to cool, allowing particles to settle and form more complex structures. Around 380,000 years after the Big Bang, a significant event occurred, changing the universe forever. Protons and electrons combined to form neutral hydrogen atoms, making the universe transparent for the first time. This transition, known as recombination, released the first light that could travel freely through space, illuminating the cosmos. This light, stretched over billions of years, is still detectable today as the cosmic microwave background radiation, a faint echo of the Big Bang, providing us with a glimpse into the universe's earliest moments. From gas clouds to galaxies, the birth of stars and galactic structures. This journey takes us back to the very beginning, to the moments when the universe was still in its infancy. The early universe, though transparent, was not uniform. Tiny density fluctuations seeded during the period of inflation provided the gravitational seeds for structures to grow. These fluctuations were like the first whispers of the cosmic story, setting the stage for everything that would follow. Regions with slightly more matter began to attract more matter, like dust bunnies gathering under a bed. This process, driven by gravity, was the universe's way of organizing itself, slowly but surely. Over millions of years, gravity drew these clumps of gas and dust together, forming vast clouds. These clouds, known as nebulae, were the cradles of future stars, the nurseries where new celestial bodies would be born. Within these clouds, denser regions collapsed under their own gravity, heating up as they contracted. This process was slow and steady, taking millions of years, but it was relentless. Eventually, the temperature and pressure at the centers of these collapsing clouds reached a critical point, igniting nuclear fusion. This was the moment of birth for a star, a new light in the cosmos. The first stars were born. These stars were the pioneers, the first sources of light in a previously dark universe. These early stars were massive, hot and short-lived, fusing hydrogen into helium in their cores and spewing out heavier elements into space when they exploded as supernovae. Their lives, though brief, were incredibly impactful. These stellar explosions enriched the surrounding gas clouds with the ingredients for future generations of stars and planets. The cycle of birth, death and rebirth was set in motion. As stars formed and clustered together, their collective gravity drew in even more gas and dust, creating vast swirling structures, galaxies. These galaxies became the building blocks of the universe. Our own galaxy, the Milky Way, is just one of billions of galaxies in the observable universe. Each galaxy tells a part of the grand cosmic story. Each galaxy is a vast island of stars, gas, dust and planets bound together by gravity. These islands are the homes of countless stars and potentially countless forms of life, each with its own unique story. A star system is born, the formation of our sun and planets. About 4.6 billion years ago, in a spiral arm of the Milky Way galaxy, a cloud of gas and dust began to collapse. This particular cloud, likely enriched by the remnants of earlier generations of stars, would eventually give birth to our solar system. As the cloud contracted, it began to spin faster and faster, like a figure skater pulling in their arms. This spinning motion flattened the cloud into a rotating disk, with most of the mass concentrated at the center. At the heart of this swirling disk, gravity pulled in more and more material, increasing the temperature and pressure. Eventually, the core reached a critical temperature and density, igniting nuclear fusion. Our sun, a yellow dwarf star, was born. So here we are, billions of years ago, when Earth was a very different place. Imagine a world without plants, animals, or even the simplest forms of life we know today. It's hard to fathom, right? But in these ancient oceans, something extraordinary was beginning to happen. Tiny microscopic organisms were starting to form, setting the stage for all life as we know it. These early life forms, often referred to as prokaryotes, were the pioneers of life on Earth. They thrived in environments that would be hostile to most modern organisms, and over time these simple cells began to evolve, becoming more complex and diverse. This gradual evolution eventually led to the vast array of life forms that populate our planet today. It's truly incredible to think about how life on Earth began from such humble beginnings, isn't it? In the grand tapestry of the universe, our species, Homo sapiens, has only just arrived. Emerging around 200,000 years ago, we are but a blink in the cosmic timeline. From our humble beginnings in Africa, we spread across the globe, adapting, innovating and evolving. Our journey is a testament to our resilience and curiosity, driving us to explore not just our world, but the universe beyond. As we look to the future, the universe continues to expand, driven by a mysterious force we call dark energy. This expansion will shape the fate of galaxies, stars, and perhaps even life itself. Our understanding of dark energy is still in its infancy, but it holds the key to the ultimate fate of the cosmos. Will the universe continue to expand forever, or will it one day contract? The answers lie in the stars waiting to be discovered. Imagine compressing the entire history of the universe into a single calendar year. On this cosmic calendar, the Big Bang occurs on January 1st, and the present moment is the stroke of midnight on December 31st. Humanity's entire history would fit into the last few seconds of December 31st. This perspective humbles us, yet it also highlights the significance of our existence. In these fleeting moments, we have achieved remarkable things, from building civilizations to exploring the cosmos. Says, as we reflect on our cosmic journey, we are reminded of the interconnectedness of all things. We are made of star stuff, forged in the hearts of dying stars. Our curiosity and drive to understand the universe are intrinsic to who we are. Each discovery, each step forward brings us closer to understanding our place in the cosmos. The journey is far from over, and the future holds endless possibilities for exploration and discovery.